Hello, this is a video on MZ, Managing Z, a systems management tool for ZVM and Z-Linux. The first question you might have is, how much does it cost and where do I get it? If you go to a Google search bar and type in MZ and Managing Z, the first hit should take you to SourceForge, where MZ is. And the good news is, it's free. It's totally open source, distributed under the Artistic License 2.0. And I should add a disclaimer. I work for IBM, but I do not speak for IBM. IBM does not support nor sell this software. On the SourceForge page, you can click on the Files tab, and you'll see there's only three main files that you have to worry about. A README, which is shown on this page, the RPM, which is installed on a Z-Linux system, and one document called the MZ Cookbook. Okay, let's go to an SSH session, a couple of SSH sessions, each on two different LPARs and two different KEKs, each with MZ installed. So there are many MZ commands. One of the more common ones is MZLS tree for list tree, and -D is for directories only. So here you see that we have the MZ tree. It starts under varlib MZ, and there is four main high-level directories. SSI clusters, which is for ZVM 6.2 and later when they're installed as a cluster of up to 4 members. Appliances, which are freeze-dried or captured Linuxes. And we're not going to talk about appliances and services. Services are simply small install scripts or service scripts that can be injected onto a new clone after deployment or after cloning. Today we're going to focus on the systems subdirectory or main directory. And you might notice that I'm talking directories, and this looks an awful lot like the tree command on Linux. That's because it is. The MZ database is simply a Linux file system, which is hierarchical in nature. So the hierarchy of System Z resources is a KEK or a mainframe, which is divided into LPARs, which can run different operating systems or hypervisors, and typically with ZVM and Linux, you run ZVM in an LPAR. ZVM can be carved up into virtual machines, and virtual machines can run operating systems, and typically that's Linux. So let's look at just a few charts. Yes, I still use Freelance, showing this hierarchy with different pictures. Okay, so 2 KEKs. Each KEK in this diagram is divided into 2 LPARs. Each LPAR runs a number of virtual machines, so 10 virtual machines. So what is the model for MZ? Very simple. One virtual machine is dedicated, or it is used, it doesn't even have to be dedicated. One virtual machine with more privilege class is installed on MZ is installed on each LPAR. Okay? Now, how does MZ communicate? How do MZ servers communicate to MZ clients? And I use the word MZ client loosely because there is no MZ client software. It can be thought of as agentless. There's only one MZ RPM, which is an MZ server. So MZ utilizes SSH key-based authentication. So by pushing its key to its managed clients, it can get SSH sessions without a password. Also, each MZ server shares its key with every other MZ server, so that when an MZ server needs to talk to a client on another LPAR or another KEK, it simply takes its key, passes it to the MZ server pushes it to the Linux on an as-needed basis, and in this fashion, every MZ server can talk to every other MZ server and every MZ client in the cluster. So this is a cluster. All right, one more chart on a little bit of the plumbing. This is another example of a KEK, and there's a number of LPARs, and the LPAR in question has ZVM installed. ZVM has a number of Linuxes installed. This Linux is the administrative Linux with MZ server installed. So it says bash because more than 90% of the MZ code is written in bash. What tools does it utilize to get its job done? The CMS FS for read-only and CMS Fuse for read-write to CMS files. These are ZVM formatted files. It uses the VMCP module on Linux, which allows it to issue CP commands. CP commands, or CP on ZVM, can be thought of as a BIOS on steroids. Okay, SSH and SSL, I mentioned that, over TCP/IP, goes through the ZVM vSwitch or virtual switch down to the OSA card, which gets you out to the network. Finally, MZ utilizes SMA Client, another open source tool, which is a bash wrapper around ZVM's SMAPI. SMAPI is the Systems Management API, which allows tools, higher level tools, to manipulate the user directory and make other CP settings. In order to manipulate the directory, a directory maintenance product must be running. Here we're running IBM's Dermate, but there are other products that can run as a directory maintenance product. Okay, enough on the charts. Let's go back to the command line. Now this is the second LPAR that is shown, and we're going to do an MZLS tree over here. So you might notice that there are 49 directories, so the two trees are identical. And what we're going to do on this LPAR is start taking the tree and taking the system apart. Okay, so we're going to do an MZ remove tree, just blow away the entire tree. Are you sure? Yes. So what's left? Is it totally gone? MZLS tree-D, and there are still appliances and services. So those directories can be mounted NFS because, especially for appliances, they can take up a lot of disk space, and that data is not duplicated. Okay. Now, when we deleted the tree on this LPAR, what happened to the tree over here? Okay, you can see now that it still has its own hierarchy on its own LPAR, but the cluster has been broken because this tree is gone, so the cluster was divided. Let's continue taking MZ apart over here. Now we're going to remove the RPM. We're going to say RPM -- erase MZ. Okay, now if I do an MZLS tree -D, of course there is no such command. So what is the size of the MZ RPM? Let's do it. ls-l *.rpm. There, this is the 2-33, and you can see it's only about 2.6 megabytes, so it's very small. So how long should it take to install? A day or a week? Let's try it. RPM-IVH MZ-. Voila, it is installed. And what I have to do is copy this one config file back to where it belongs. And let's look at that real quick. cat/etsy/mz.conf. And one important setting is host DASDs. So that tells MZ the DASDs are the mainframe disk that are owned by this system. ZVM and in the entire mainframe ZOS often share DASDs among LPARs, and it's a double-edged sword. It allows you to get access to other LPARs DASDs, but it also allows you to write over them. So this tells MZ what DASD we consider read-write on this system. You can also say what FCPs and what OSA devices, temp VDEV, tree color equals green. That is just a setting for your favorite color for the highlighted text. Use SMAPI. This is an important one. SMAPI does not need to be running for MZ, although it's recommended. If you do not have SMAPI, which this ZVM LPAR is not running SMAPI, if you do not have SMAPI, you can get much of the work done, but not everything. With SMAPI, you have a complete set of function. With SMAPI, without SMAPI, you have a subset. Okay, now let's continue putting this LPAR or this tree back together. We're going to say MZ make tree with no arguments, and this will take a few seconds because it's going out and investigating, this warning's okay, it's investigating its environment and copying files. So now if I do an mz ls tree -d, you see it has put back together its cluster. And I should point out that I've been showing the tree with just directories, but a lot more data gets copied. Like all of these files were just copied, all of these Linux files were copied, and all of these ZVM files were copied. Okay, some are files and some are really information. Okay, so in a sense, MZ is a poor man's high availability and a poor man's backup tool, in that it saves important files and replicates them across the cluster. All right, so let's add a managed client, because right now in the tree we only have the MZ server. So we're going to say MZ add clients. PBC 4545 is a Linux that is running. Now that had been in the tree previously, so the key-based authentication is set up. So it just got added. Normally you would be prompted for the password, and now we can see that we have at least one managed client in this LPARS tree. So let's put the cluster back together again. MZ add server ZNTC72, which is the MZ server on the other LPAR, which is on the other CAC. Okay, voila, that was fast. Now if we look at the tree, we're back to 49 directories. If we look at the tree on ZNTC72, it has put the cluster back together again. So this has shown destroying an MZ cluster, uninstalling the RPM, reinstalling the RPM, and putting the cluster back together in just a few minutes. Now, one more thing I'm going to do over here is edit a description. So let's say PBC, let's say ZNCT72. So we're going to do MZ edit description of ZNCC72. Okay, this is really Mike's main development server. Okay, so what did I do? Every object in the MZ tree has a description and an owner file associated with it. And we're going to see that later in the second video. So for now, this is the end of this video. I've shown you MZ at a high level. I've shown you some operations and some commands. And the second video will focus on the GUI, which is a web interface. I hope you've enjoyed this. Thank you.